Alright, hello everyone, this is Mr. Carson. I'm going to walk you through graphing this parabola. So we have this equation right here, and it's from problem 3 in the worksheet. But this equation, and we know it's a parabola because we have a squared term and a regular term. So what we want to do is we want to put this into standard form, identify the parts, use our table, make a quick sketch, and then make a really neat graph at the bottom. So, alright, here we go. Well, I want to get my x's together, so I'm going to have x squared minus 4x. And over here on this side, I'm going to have my y's. I'm going to put add this over here, so I have 12y. Subtract this over here, I have minus 16. So I have my x's on one side, my y's on the other, and I left this room here so I can complete this perfect square. And I always put a plus in a spot here to complete the square. And if I divide this by 2, right, it's going to be b divided by 2 squared. So divide this by 2 is 2 squared is 4. 4 is the number I need in there. And what that does is it allows me to write it in this format right here. So I have x minus 2 squared. If I FOIL this, I'll be back to here. So keep that in mind. That helps you figure out that number. And over here, what is this? 12y minus 12. And that's very close. However, we need to separate this 12 from this y. So it's x minus 2 squared is equal to 12 times y minus 1. And there's our formula. There's our standard form. It's x minus h squared is equal to a times y minus k. And there's our formula. So taking this, we transformed it into here. Now that we have this, it's easy to graph. The vertex are just the points that zero this out. So we have 2 and 1. Now the direction, it is an x squared parabola with a y, and that's our normal parent function, and it's positive, so it's just going up. So now I can come down here and just do a quick sketch. 1, 2, 1 right there, and the parabola is going up, so it's going to look something like this when I make it neat. The axis, well, that's going to be right there, of course, and that's x is equal to 2. The directrix is going to be this line down here on the other side below it, and the way we get that is we take this a value, which is 12, so it's a divided by 4, so, whoops, a divided by 4, just have to memorize that number 4, and it's 12 divided by 4, which is 3. So that means what I do is I start here and I go down 3 spaces. 1, 2, 3. And there's this line that we're going to talk about later. And this line right here is 1, 2, 3 spaces down. So that line is y is equal to negative 2. And now the focus, again, we got to use this number 3. We go up 3. Right now the point is at 2, 1, and we're going to go up 3, 1, 2, 3, add on 3, 2, 4 is the focus. There's this point here. And what that point is every spot on this line from here to here is the same distance. Now you really can't tell with this picture. Whoops. Can't really tell from, it goes all the way down to here. You can't really tell from this picture, but when we get lined up down here on the good graph, we'll see it. All right, one last thing we need to do is learn how these points change right here. Well, this is a normal set of inputs, and this is a normal set of outputs when you just have y is equal to x squared. However, we have a factor of a, and usually the a is over here, but it's over here, so we're going to divide by a. My a value is 12, so 0 divided by 12 is still 0. And 1 divided by 12 is 1/12, and 4 divided by 12, well, that's 1/3. 9 divided by 12 is 3/4, and 16 divided by 12 is 16/12, which is 1 and 1/3 left over, right? Divide that by 4, divide that by 4, we have 1 and 1/3. All right, now we have a lot of good information to draw a neat graph, so here we go. I'm going to start with my vertex, which is 2, 1, so over 2 up 1, there's my vertex. It's going to go up, but I don't want to guess where it's going to go up because I'm going to use this to figure it out. The axis of symmetry, that's an easy one to draw, so I'm going to come right down here and draw this. There's my axis, that splits it into 2 halves, and my directrix is y is equal to -2. So I'm going to go this way, and I like to do these as dashed lines. And now I'm going to have focus 2, 4 over 2, 1, 2, 3, 4. And right here you can see this distance from here to here is 1, 2, 3. This distance here is 1, 2, 3. Now I'm going to use this table, and I know which way it's going. It's going up. So watch what I do. I start at 0, 0. Good. I go over 1. This column's out. Over 1, up 1 12th. Well, that would be up very little. Over 2, up 1/3. Well, that's not too much more. Over 3, up 3/4. Over 4, up 1 1/3. And there's the shape my parabola takes. It's really wide. All right, now I'm going to do the same thing this way. Over 1, up 1/3, 1/12. Over 2, over 3, over 4, and there's a parabola. There's a direction that parabola takes. And if you have a highlighter, it's good just to go back and highlight this. You can make your point stand out if you want to. You can go back over these and go this way. And you might want to make this point stand out. It's kind of like the center of it. And here's where we can see this, what the directrix is. What the directrix is and the focus is, if I were to draw this line here and this line here, those lines are going to be congruent, that distance. And if I were to come out here to this one, now I have a longer distance. Now I have a longer distance this way. And every point on there, if I come out to this point and I come down to that point, 1, 2, 3, 4, 1, 2, 3, 4, those are all the same. That's what these 2 points give you. Same, same, same. That's why we have them, and that builds a parabola. All right, hope this helps. This walks you through all the steps of taking this initial equation, finding out a lot of information about it so we can draw a really neat graph at the end.